Hi everyone, and welcome to today's Physics Daily Booster. This is number 11 in the series. While what we're doing today isn't explicitly listed in the advanced information, that doesn't mean there won't be questions on it, as we've seen from the earlier paper. So it is worth making sure you know the entire course, because as we know, there are no topics that will not be assessed on this paper. We're going to be looking at static, basically. So let's start off with the most basic facts. When we're talking about a proton, they have a positive charge, electrons have a negative charge. And this little table should look really familiar to us from our chemistry. We've got our three subatomic particles, protons, neutrons and electrons, and we need to know the relative charge and the relative mass of each of them. So remember, the relative charge of a proton plus 1, relative mass is 1, neutron is 0 because it's neutral, and the mass plus is 1. And then the electron minus 1 for the charge, and its relative mass 0.0005 or 1 over 2000. Now remember, the reason that atoms are neutral is because they have the same number of protons as they do electrons. Protons are positive, electrons are negative, they cancel out to give a neutral charge overall on the atom. When we generate a static charge, what we're actually doing to achieve this is rubbing two insulators together. So if they ask you a question about how can you generate a static charge, rub two insulators together is the answer. The explanation of what's happening is that electrons are being transferred from one insulator to the other. Key point, it is only the electrons that move. Nothing else moves, just the electrons. So that means one of your objects, the one that gains electrons, is going to have a negative charge. The one that loses the electrons is going to have a positive charge. Depending on what the material is, then it will determine whether it's going to gain or lose the electrons. Now I expect you did this practical in class where you had the different rods made of different materials and a bit of cloth like a duster. You rub the little rod and then you'll see that it will attract or repel water. So you probably had a little stream of water on the tap, moved it near and it either attracted it or repelled it, depending on the charges. Now, what we find is, as far as acetate goes, then that one is going to lose electrons. It's going to transfer the electrons from the rod to the cloth. So that means the rod becomes positive, the cloth becomes negative. If we have a look at the situation with polythene though, it's the opposite. So in the case of polythene, what happens is the electrons are transferred from the cloth to the rod. So that means the polythene rod is negative and the cloth becomes positive. As far as interactions with charged items goes, just two very simple rules to remember. Opposite charges will attract, like charges will repel. What we find then is if we've built up this static charge on an object, then there are a couple of ways it can now discharge. First of all, if we connect it to a piece of metal, then the charges are able to flow and discharge it. Secondly, if it's not connected onto a piece of metal, we can generate a spark. You might have seen this where you take a jumper off that's got a load of static on it, then you get these little sparks actually jumping if you see it in a dark room. Now, those sparks are obviously releasing that charge from the object. So we do need to be mindful of those sparks because depending on the setting, they can be dangerous. What we actually find then is if we consider what is in place around one of these charged objects or charged particles, what we have is a field, an electric field to be exact. So what we actually then end up with are field lines that probably look quite familiar to us from when we've actually sort of done the magnetism side of things. So if we've got a negative and a positive, then what we will find is there are field lines that run between them, and notice how the arrows go from positive to negative. Okay, so remember, positive to negative is the direction of any arrows. If we've got two of the same charges, so the second picture we can see two positives, then they will repel. So what we can see there, we've got the arrows pointing away because it's positive, and those lines are not actually going from one charge to another because they're repelling, so that means they're going to bend away from each other. So that shows how we get the attraction and the repulsion. If they were to ask you to draw a diagram to show what happens when two opposite charges are placed close together, we would draw the top diagram, remembering to include the arrowheads going from positive to negative. If they were two like charges, we would draw the bottom diagram showing that the lines are bending away, not going from one charge to the other. The reason for that is that if we actually place a charged object in the electrical field of another, then we're going to lead to that stretching of the field lines. Now, when we've done that, we actually end up with a force being exerted on the object that's going to be in the same direction that causes those field lines to shorten and straighten. And this is going to be quite an important point when we come to look at some other interactions later on. If we're looking at a little diagram and they ask us which has the strongest field, then basically look for one that's got a lot of lines close together, because the closer together the field lines, the stronger the field is. And of course, don't forget the direction, it always goes from the positive. Don't forget to join us tomorrow for our next Physics Daily Booster. If there are things that we've covered today that you're not 100% certain on, then obviously you do have the main video channel, and you do also have things like your revision notes that you can use to support you in that. It is worth making sure that you know at least the basics on this, because we do know from the first papers that as much as they've told us some of the questions, they certainly haven't told us all of them. So it's worth making sure you are confident in as much of the course as you can. Look forward to seeing you again tomorrow then, folks.